All right, so welcome to this month's GDG Gigcity. We are talking building websites and applications in Go, and I'm going to be hosting this on the Google App Engine, so we'll be covering some of that. And so there's not going to be any Polymer bits, unfortunately, but we can work around that. So I've already have a site already laid out. There's several points in developments that I've tagged, and we'll just walk through it, and feel free to ask questions if there's anything you want to know about or anything that seems odd throughout this. And it'll be a fairly loose structured meeting, and hopefully that'll help drag it out, because I don't think I can go an hour on this because it's so simple. So first, to do a app engine application, you need the SDK, of course. You can download that from developers.google.com, and then once you have that, the way you define it is within the project there's a app.yaml file. Let me size this up some. And so within that you actually define your application structure. So let's open it up. And if you're familiar with YAML, then it'll look very straightforward to you. So the first thing that you do is your application. That's a unique key to that application that's going to be running there on the App Engine. So in this case, I'm calling it Gigcity. Then the version constraint there is the version of your application. It supports alphanumerics, and so you can have version 1, and then if you want to do A/B testing, you can have version 1A and version 1B, and then it'll switch between the two. The runtime tells it what it's actually going to be running on, and so in this case ours is Go, but if you were doing Java work, you'd put Java there. If you were doing Python, it'd be Python 2.7, because they don't support 3 yet. If it's PHP, you would just put PHP. And then the API version tells it that we're using version 1 of Go. Now, the handlers, you list any URLs that it needs to be aware of. And the URL is actually regex, so that would hit any URL. And it's telling it to run it to our Go application instead of handling it special.
So that's what that dash in front of URL is. That's a section. Then you do one, and another one would be dash URL, and then
and you want to list them, so that will be your bottommost. So if you want to have a directory within here, you would list that one before you do your /period asterisk.
Yeah.
Since it's doing regex matching, it'll match the most specific to the least specific.
What do you say you have to download to do this?
The SDK.
Yeah.
And you can get that from developers.google.com.
Okay.
So if you come here in the products,
Okay.
it's under the cloud.
Cloud. Okay. So the Google Cloud SDK, is that it?
Yeah, you can do that one, which will give you all, so it'll give you the App Engine stuff, the Compute Engine, and all that. Or you can just specifically say you want App Engine.
App Engine, okay. All right.
and they've got a freebie one that is
It's
tiny.
the way they work's interesting. So they have the free tier, and then they have the billing enabled, and everyone gets the free tier, and it works off of daily quotas. So let me see if I can pull up the quota listing. Actually,
Do you have to install that? Does it run a program, or can you just unpack it to a directory?
it's I don't know about all of them. I know the Go SDK one, you just unpack it to a directory and make sure the binaries are in your path. If you're running on Windows, though, it may be different.
Python one runs all the time and it wants to update and it drives me crazy. Just uninstall it.
you install Go on Windows, then you do it the same way, you just unpack it, you don't install it.
Yeah, that's how you would do it for all of them. I cannot find the information on the quotas for some reason right now. But it's just a daily quotas per thing. Uploading, yeah, it should somewhere here have a link to the quotas. Yeah, here. So this is, we'll start from the top. So they go by resources. So you have a quota for the blob store, which is used for storing files. Any channels that you create has a quota. You have a code and static data quota. A data store, which is a NoSQL high availability database. And then you have instance hours that they track, logs, emails, things like that. And they're done daily, so they reset every day at midnight.
What is their concept of a channel?
It's like web channels, things like that. So it's just a different type of connection that's constant. So like the Google Cloud Storage, on a free tier, you have 5 gigs daily that you can store up. And then from then on, they bill you. They used to say the price, but it's usually fairly small. There's no maximum. They'll just charge you for whatever you go over that in a day. So if you have like 5 gigs and like 5 megs worth that you hit, they only charge you for the 5 megs that you went over. Yeah, so and then so for channel API calls, on a free tier you have 657,000 calls you can make daily. The max rate is 3,000 calls a minute. Now if you enable billing, that goes up to 91 million and all that. And so they limit you on channels. And then channel hours, so you can only keep a channel open for 200 hours or 12 hours requested per minute. And then, so for the code and static data storage, you get a gig free. And then if you go over that, it's like 0.03 cents a gig per month.
It's cheap.
And they practice Moore's law. So as data gets cheaper, those prices get cheaper. And so,
And the way they would charge you would be through your Google account?
you put it in a credit card.
Oh, okay.
And they bill monthly.
Okay.
So they just track how many times and how much you've gone over each quota daily, and then it'll accumulate up, and then they'll give you a bill.
Right, yeah, I mean, you need to give them a credit card anyway, because you might not go over, but you might. Right?
Yeah, and if you don't go over, they don't charge you.
Right, yeah.
And so, which one is this one for? Is this the data? Yeah, so the data store. So you get a gig of data store that you can have, or you can go have no maximum if you enable building. And they limit read ops if you are free. Otherwise, it's unlimited. But still, 50,000 is a lot to do in a day. And then
10,000 deployments a day.
do what?
10,000 deployments a day. So we're talking about continuous deployment.
Really?
And so and then they have a concept of a front-end instance and a back-end instance. And within front-end instance, you have 28 hours a day that you can do free. And then a back-end instance, it's 8 hours. And then they charge you for log storage. but you get 100 megs free, and for data retrieval, and then you get a gig of actual storage. The mails are also limited because they don't want you spamming, so that's why they have limits even on paid.
So you can't do more than 1,700,000
In a day.
in a day.
Can't spam the whole world anyway. So.
No. And then they have bandwidth, and you get a gig of bandwidth a day.
Plenty to play with.
Oh yeah, it's very nice. Then you can do full text searches within your application. They let's see, it's not very impressive, only a quarter of a gig, but
So this is per application.
yeah, this is per application, and it resets daily.
So
And you can
get
have
10 apps.
you can have
Yeah.
10 applications, and if you go over that, they're willing to work with you. So all you have to do is contact the Google support and say, "Hey, I needed more instances," and they'll give you permission to create more.
So is this closer to a PaaS offering then? It's like they're hosting your app, but are you going to be able to get to the command line and play with the Linux? prompt?
No, not through the App Engine, but if you're using a managed VM, yes.
Okay. So this is more like a PaaS offering.
Yeah, this is this is a PaaS rather than an actual system.
Yeah.
But it has its advantages because it automatically scales and will scale back. So as there's an increasing demand, they'll increase the number of running instances for your application. Therefore, it can handle the load it's getting. And then once that load dies, it'll start killing those back to save on your resources.
And that counts against your 10 apps as it scales out?
No, it's
okay.
you can scale out as much as you need.
Because all these other limits will restrict you.
Yeah.
Yeah.
And then if you're on a free, once you hit the quota limit, what they do is they just cut you off for that resource. So if you're sending out a ton of emails and you hit that cap, it'll send an error back to your application saying that your quota has been exceeded, and it'll just refuse to send any more for that day. But the rest of your application will run fine. And then it can also send XMPP calls, so you can do like instant messaging and things like that. So the abilities that you can do with it is wide, and the quotas are more than giving. And then once you install it, at least for the Go, you have a command that's just called Go App, where you do everything. So you can run your development server by saying Go App space serve, or once you have it ready to have something where you're ready to push it up to the App Engine, you say Go App deploy, and it'll push everything up. But let's not get to that yet. So within here, I have a single Go source code file and a directory called static that just has a directory for an image. But there's nothing really in there yet. So if we look at the source code for this that's running the actual application, it's very simple. So we define our package. It's just a unique name that you use constantly throughout all your source code files. So if you have 2 or more files that make up your application, they just need to have that same package name. And then we do our imports. So right now we're importing our format package as well as the net HTTP package, which actually allows us to run the server and handle and make web calls. And then we have a single function for init. And the way the App Engine works is a bit different than you would if you were just going to build out a binary and put it on your server yourself. Here, the App Engine actually runs its own special main function, and it just imports your code as a package. And so you don't define a main. And so we put all of our routes within the init, or call a function that defines them within init. And so here we're doing HTTP calling the handle function, which is saying for this route, call this function to handle it.
If you're doing routes inside the code, why did you have to do something in the config file?
That way, if it has other things, so you can tell the App Engine to serve static files from a certain directory or things like that, or if you have specific routes you want to do different things with, you define them there so the App Engine knows how to handle it. We'll go into more of that detail, like authentication. That's one of the things where that comes into play. And so with this, we have our root handler function that we define. We pass in 2 arguments: a response writer, which is actually writes out everything and sends it back over to the wire to the person who made the request, as well as the actual request itself. And so here, when we get a request, we just write hello world to our response writer, and then that's it. And we can actually run that by saying go app serve. Now the interesting thing about this is it actually mimics the entire Google App Engine infrastructure. So we have 3 actual ports that are of key interest. So we have an API server that's running here. We have our actual application, which is running on port 8080, and then we have an admin server, which is a backend interface, so we can see how things are going and actually work within the application there. And the API server mimics everything, so if you're making a call to like the email, that fakes up the email APIs and everything.
So that's for that locally running app to use. You aren't going to...
Yeah, that's just for this thing to see. So like here's the admin interface. So you can see all instances that it's currently handling, the latency of it, and the number of requests made from that, as well as see the data store, which those are not actually accurate, but we'll leave them. Those are for a later version of it, but it's a simple NoSQL works, kind of like a key value, but not.
How do you get to the screen here?
So this is the, if you go to localhost 8000,
Yeah.
this is our admin server.
Okay. That's what you just defined it for 8,000. Oh yeah, right there. Okay.
Yeah.
Okay, got it.
And so within here you can inspect all the data within the data store, as well as stats that get stored within it. You can see information on any indexes that are defined, because the data store relies heavily on indexes in order for it to be quick and efficient.
When you deploy it, will there be an admin port?
No, this interface gets replaced by the administration console,
That makes sense.
which is more powerful than this.
Right, that makes sense.
This is just here for development.
Yeah.
And then you can also generate stats on the data store itself. Now, while this is running live, these will be done automatically for you periodically, but within your development environments, it doesn't do that. So anytime you need to get those kind of statistics, you have to click the button. And then those get stored in to these keys here. So let's just list that one. Yeah, so we only have one entity created on here. Let's do the total. That should be fairly large. Yeah, so now we can see how large our index is, our index counts, and just and information like that. Now, I don't think the Go version of it supports the interactive console yet, so there's really nothing there. You do get a free memcache server though, so you can work with it here, and there's a light version or a slimmed down version of memcache that runs within the development server, so you can, if you have anything within there, you can see it and manipulate it within here. If you're making use of the blob store, all files and everything will be shown here, and you can delete the files as needed. You can schedule tasks, which work differently than cron jobs in some way, but not quite sure how. But you can manage them there, or if you have cron jobs, you can see them here. You can fake out sending chat messages and things. It won't actually hit any servers, so you can't actually message a friend through here. And then email-wise, it only works inbound. It won't let you send outgoing emails. So this is to test how your application handles someone sending an email to some email address your application is supposed to parse. You can use this and fake that out and test your application.
So when you press send, it's going to send to the locally running app, but not out
Yeah.
to the world.
Yeah, so even if I put in my email address here, it won't send out to the world. And then if your application makes use of full text search, you'll be able to manage it within here. So now that we've walked through that, let's see our actual application. Very fancy and super quick. Let me do this without caches. But then again, there's nothing to it. It's just printing out hello world. And then this also washes your files, so you don't have to shut this down while you're working. You just go to a new terminal and you can continue working from there. It will see any changes to any files it needs to actually reload or recompile and do that for you automatically.
I think you said something about a config file there.
Yeah, it's that app.yaml.
Yeah.
That's the
Oh, yeah,
only,
okay, that's
yeah.
it. Okay.
Yeah, so it just needs that so it can define how the application works. And so let's switch to a more advanced one, and I wish these were in better order. Let's do, I think the template was next. Yeah. Alright, so in here, there should be at least, yeah, so within the static, now we have a file called _base.html and a file called index.html. These are template files that Go will parse because they have a built-in templating language. If we look at one of them, it looks fairly simple to pick up. It mostly stays out of your way. You're just writing HTML most of the time. The only time you actually hit something specific to the template is here on line 21. And that's saying find the template that defines content and put it here. And that period tells it that if there's any data that we're rendering, if we pass it any variables or anything, also send those variables to that template. But other than that, it's just plain HTML. This is using Bootstrap, pulling it from a CDN, and using Google CDN to pull in jQuery. Now, if we look at the index file, right now it's just defining that template and just gonna shove in hello world, but it'll be formatted in proper HTML. To have this actually work, we need to tell our Go app to actually parse it. So we are replacing the format package with the HTML template package. And then we're altering the root handler to actually make use of it. So what this is the must function within the template package says that if these don't build, then there's an error within the syntax, and then just die. Don't even bother trying to render it any further because it's not going to work. And must takes in a glob of the templates. So we do parse files and give it a list of all the files for it to read in and create that. So in this case, we're pulling in our static base.html and our static index.html. And then the execute line down here is actually what renders out the HTML and everything, and then we write it into our response writer. The nil here says we're not giving it any variables or anything that needs to parse and render in. It's just read in the file and then just give me HTML that I can send out. So if we were to reload this, there won't be too much of a visible change, but if we actually inspect the HTML, it actually has a structure. So it has all that HTML that we put into our templates, and here's where it's dumping in the hello world.
Is Google Trans, is that injected? Script window, Google.
Where
Maybe it's extension or something.
the screen capture injected?
That thing?
Oh. Yeah, that's just a injected value that Chrome's doing for checking to see if it needs to translate the page.
Oh.
And like these bits here, the screen capture injected and the class has Google Voice, those are injected by a plugin in my browser. But still not very complicated, and also the application itself is still fairly simple, not much going on. And in all that, we didn't have to make a change to that. That's the same app.yaml that we've had in the last one. So
What's in the tags file?
oh, the tags is just the C tags, because Vim knows how to parse C tags out, and so that I can just jump through tags and
Oh,
everything.
that's for Vim. Oh,
Yeah.
okay, gotcha.
All right, so let's see. So now let's style it. And so now there shouldn't be any changes to our static. Okay, no, I did something out of order now.
What is GA?
Oh, it's a shorthand to Git.
What?
It's
GitHub command line client?
yeah, it's technically GitHub command line client, but it's a wrapper or re-implementation of Git and Go,
Okay.
and it's actually quicker than the actual Git is, and it allows for special functionalities.
Okay.
So I can say GitHub clone, and then my GitHub username / and then a project,
Yeah, okay.
and it'll automatically just pull down that project.
Okay.
See here. I think it should have been. Wait, no, that should be right. All right. So now we have two extra files, a 404 and a 500. And no, error handling was next. That's where I introduced those. Yeah, this is where I wish I had notes. Yeah, they should still be there. If we open up the actual application, so we introduced a new function here, a error handler, and then this one actually takes in 4 arguments. It still takes in the response writer and the request, but it also takes in a status code, which is a int value, and a error message, which we pass in as a string. So what happens is if this gets called, we are going to write out that status message into the header. So instead of sending a 200 OK, we will send back a 404 or a 500 or 403, whatever our value was. And then we do a switch on that so we can determine how to handle it. So in case of a 404, we'll pull in our 404 template and render it and send it out like we normally would. And if it's a 500, then we do the 500 .html template and do the same way. Now there's some difference here though. So if this page.execute was to fail, we recursively call the error handler function, but give it a status internal server error. Now if the status internal server error was to fail, then we just fall back on the default http.error message, which just gives a white screen and then that error message. And then within our route handler, we want to make sure that we get only specific routes. So if we get a route that does not match anything, which in this case, the way it works is this is regexed, so the / there matches any route. But if the route was something other than just a /, we treat that as a 404 and call the error handler, otherwise we process it. So we can do this, we can test that by coming in here and say /, we still get our hello world. But if we come in here and say /foo, we get our 404, which just says file not found, which is defined there. So just added just a little bit more complexity to it, but not much. Now let's go back to the other one I was at. The basic formatting. Now most of the changes here is actually going to be within our files. I think index is the same. Oh, no. So here we're replacing the index with actually something that we want to be seen. So we're defining a bootstraps jumbotron and putting in some content there. So right now this is all just static within that template, and it gets pulled in if the root page gets hit. And the base actually has some changes to it as well. We have a little navigation added to it as and it's just the standard bootstrap nav bar. Now if we look in here, since we're serving an image, we need to be able to handle that static file. And so the way we do that is by telling the HTTP package, calling the handle function, give it the route that we want to match. So in this case, /static/image. We want to do a strip, so we pull that bit off. That leaves us with just the file name that's been requested. And then we call the file server, which takes in a directory. So our static/image directory.
Didn't we configure a static directory in
Not in the app.yaml. All that knows is to match anything and send it to our Go app. So this thing's now having to handle the statics. And that's the only change between the last one and this one, code-wise, is just that one line of code. And we can see it handle those if we go to that directory. So we have the chapter logo /rgb.ping. And if we click on it, it'll actually open it. It serves it just like any other web server would. But if we go to the home page, we actually have something that looks like a website. And then let's see. So a one-page website's not very useful. So let's add in some more stuff. So if we look in the statics real quick, so now we have a about.html file added. And then that has our markup for the about page. Again, just standard HTML, stuffed it within the template file, and that will just get pulled in via the templates calls within our app. Now we have to add the route to call that within our application. So to do that, we just add another handle funct call, passing in the /about path and telling it what function. Now you have to do it in this order since it's regex. So if you accidentally had it that way, the about page would never get called.
Because it would match that.
It would always match the /. And so with that, we've also added in another function call. It looks fairly like the roots, except we don't have to worry about handling 404s anymore, since that's always going to fall onto the root handler and get matched there. So now what we have to do is just pull in our template files, render them, and send them out. And I believe the links should work. Yeah. So if we were to click there, we're now on that page. And then this is responsive since it is Bootstrap. So someone pick a device.
iPhone 5.
iPhone 5. And let's refresh this so it will actually get the proper media query sized.
And that is even got the little menu.
Yeah, and so it translates. Yeah, it translates the clicks to an on-touch event. So if you have JavaScript or whatever listening for on-touch, then this will still trigger those. So let's reset that and get back to full width. And still, that was a fairly quick, easy change on that. And so let's move on to let's see. The events was next. So within here, we have yet another page we've added. So events.html. This one's going to be a bit different though. And we also have an admin folder. I'll overlook that one. And then the admin folder has a second page called add event.html. We'll go into that one next. We'll go into the actual events first. Now this one's has a little bit more logic to it. And so this one's going to loop this bit for because we're going to pass it in a slice, and so it's going to range over that slice and run this bit here once per item in that loop. And so it's going to put it in a bootstrap panel, give it a title of pull in the title from the event, and then it'll pull in a date, time, and then details. You access all variables within here by dot and then the name. And we'll see where it's getting the name from here in a minute when we look at the code. And then the admin one's doesn't have much logic to it. It's mostly just drawing out a form. So it just does a standard HTML form. It has a input for a title, using the HTML5 date time locale for a date picker, and then a text area for details, and then a submit button. And if we look here, so now we're having to bring in some non-standard. Up until now, we've just been using standard packages that come within the Go language. And so now we're having to get into App Engine's stuff. And so there's the general App Engine package. There's a package to access the data store. And then there's a package to access all the user information, which is how you determine authentication, things like that, is through calls on that.
How do you get those packages?
Those come with the SDK. So when you download that SDK, it'll have those packages in it. We also need a way to store our data. So we define a structure called event, giving it those 3 data types. So our title, date, time, and details. And then we're defining 2 extra paths. So we're defining a admin events add and a /events. And since this one has admin in it, of course we're going to want authentication. We're going to want to make sure they're authorized. And so the App Engine handles all that. And we define it within the app.yaml. I'll show you that here in a minute. But let's go and actually look at those functions real quick while we're here. And so this event list. It's just a simple helper function. So it takes in the App Engine context, which is per request. So every time you hit this and a new context is created, it's created off the request, and it uses that to determine if this is a new visitor or if it's someone who's been here and just clicked a different link or went to a different page. And so we get a key based off of that information and send it back. That comes in handy when reading in from the data store. But before we do that, our add event handler. So first, we grab that new context, we pass it in the request variable, and the request structure, and it'll determine if it's a new person or if it already exists, and then once we have that, we call the user current, passing in that context. Now, if they've already been authenticated, it's going to know, and so it'll just pass back or return the information. Otherwise, it's going to return a nil value, in which case we can detect and force them into a login string. And so we call user.login URL, giving it a context and the actual URL to our application, and then it handles everything else. It directs them off to Google, where they get the login prompt. They have to put in their username, password. If they have two-factor enabled, it'll challenge them for that. Or you can also do a OAuth, but if you do that, you actually have to implement the actual authentication stuff within your own application, rather than letting Google just handle all that. So if for some reason that fails, we call our error handler, telling it internal server error, and then sending them off back to the main page. Otherwise, we set a location for a redirect and set a status found to the header. And that's all you have to do to check and force authentication. So now we can get into the actual logic for this, and it's going to have two modes. So it's going to post, so when the form's submitted, it's going to handle the post, and then also handle GET requests. And so if a post is sent, we create a variable of our event, and we just populate everything, because the form value function actually will go through and sanitize everything. So it will escape HTML, escape CSS, it escapes JavaScript, XML, all that. So you don't have to worry about cross-site scripting or anything. It escapes all that, and then we just pull the data back. So once we have that, we want to write it somewhere. So we make a call to the new incomplete key for the data store, and that returns back a index key to where we can write within the data store. And then with that, we just call data store put, giving it in our context, which has just the session information, and that key we just got back, and the data. Now, this may be one thing, or it may be tens, or it may be hundreds. You just pass it all into that in one single call, and it will handle everything. It'll loop through, writing it out into new rows. And so you don't have to worry about any of that. That's all been worked out for you within the App Engine infrastructure.
Why does data store put the context or the session?
It stores that, it uses that to help build off a lot of the information. So if we come into here, it used the context ID there.
Okay.
And then this key value here, that's what the new incomplete key function call returned. So that's just the primary key for that. So once that's written, we have no errors, then we redirect the user back to the /events page where they can view that event that just got created. Now on a GET request, they're wanting to see, we need to send them the form, so we just pull in the templates and send out the HTML, and we're done. And then I have this else here just to print out any other methods. Typically you may want to display like an error message saying that that method's not supported, or force a redirect or whatever. You can just handle it like that. And so now onto our event handler. Now this is going to have to read in those values from the data store and then display it. So we need to pull in our context again, And then we don't worry about authentication because anyone can see this because it's just a view only. But we need to make a query, so we call our datastore.newQuery. Events is the entity, which is their version of a table. And we say it's an ancestor because that allows for hierarchy. So you can say that this is part of that record, or this is the parent of that record, and that record is the parent of that record. So you can have a parent-child relations within your data. And then it pulls in that event list to grab the keys from the events table. We're going to order it by date time descending, which is why it has the minus, and limiting it to 10. So once our query is constructed, we create a place to put it all. So we make a slice of events that starts off at 0 and has a maximum capacity of 10. Since we've limited our query, we know we're only ever going to get 10 back. So then we call queue.getAll using that context again, and then we pass in the events as a reference, and it just writes the data into that slice for us. So once we have all of that, we have our data. We pull in our template files. We call page.execute, but this time instead of using nil, we're passing in that slice. That way we can access it within the templates, and it can parse it and replace values. And then that's all that it needs to do. And to see it in action, let's reload this, and we can visit our About page. Oh, that link's broken. Events page. So we have two events, this event and a test one. One thing to note that may want to get cleaned up is the timestamp. It's a bit odd. It has the date and the time separated by a capital T. That's not exactly user friendly, and we'll fix that in a later version. Now for creating new events, we will go to admin events add. There's already a user logged in. New browser. Alright, so we'll go to admin events add, and then the App Engine doesn't actually, or the dev server doesn't actually send you off to Google, but they do implement you just give an email and you have a checkbox whether or not they're an admin. So we'll say the user is, so we can view this page, and we will log in, and ta-da. And that admin check is done within the app.yaml. We defined a new route. Anything that begins with /admin, we still pass to our application, but it requires a login level of administrator. And that gets set within the app console later after you deploy. You give it the counts and whether or not they're an administrator or a developer, and anyone else is just a user. In which case you would just put login required.
So how come the sequence of those URLs doesn't matter in the YAML definition?
This one not so much, but once you do static files it will matter. So I've actually had to go in and swap around my ordering in a later version of the site in order to get things to work. So we'll put in a test 2. Now the HTML date time thing automatically gives me a date picker. I didn't have to pull in a jQuery one. I didn't have to do a third party. It's all just built into the browser, assuming it supports HTML5. Otherwise, this will fall back to just a text input field. So we'll say it's, so we'll just rename this to then we can put in a time, so we're at 6 p.m. And we just submit that. It already wrote it, sent us back here where we can view it. And if we come into the admin console and refresh this page, we'll see a third row show up. Now, one thing to note, these aren't in order as they're written. Like, here's the first one that I did, the test one, and then here's the one we just created, and then there's the previous one. So there is no set order to the way it's done, but that doesn't affect your queries or anything, because you're going to want to, within your queries, you're going to order by something, say like date, time, or some other value.
Looks like it's ordered by details.
It could be. It could do a string sort there, but there's no necessary format on it. I think it's off of the key or the ID. Yeah, it's one of those. But see, it's the way it jumps. So we have that. It started at 53, and then the second one created was 58, and the one we just created was 57.
Yeah.
So there's no exact order to it. It's just the way they're displaying it. So, and that one's broken too. Alright, we are done with this incognito now. Alright, so let's move on. Yeah, let's fix that. So we'll do the the C is just alias for checkout. Yeah, so we're going there. So this one we are doing some logic that changes the way the date times are displayed for the user. And so all of our changes are within the event handler function. So within here we're introducing a loop. We're going to go through that events structure and take the year, month, day, t, hour, minute, and turn it into a year, month, day, space, hour, minute format. So the way we do that is we range over the event structure, and that breaks it out into a key value, which in this case is our index and our data. And so we bring in the time func package, and we call parse, giving it the format that our date time string is currently in, and the data that we want it to operate on. So event.datetime. Now the way they Go handles the formats is a bit odd. They don't start at the Unix epoch or anything like that, and they don't use letters. Instead, it's January 2nd, 2006, 3:04 p.m. I don't know. I don't remember the exact reason why they chose that, but anytime you have to give it a date, time, and string, so to format anything, you have to give it that date and time.
The January 6th one?
The January 2nd, yeah.
Second. How about that? That's somebody's special day or something.
Yeah.
It's somebody's beginning of time.
Yeah.
And so we run that through parse. We get a I hesitate to say object since there's not really objects, but we get a time value back if it was successful. And then from there we write it back into our slice using the key so we can write it back into the right place. And we call t.format and specifying the format that we want. So we're taking out the t. We're going to use 12-hour time instead of 24. And so we're going to want to add in AM or PM. And so once that's been done, the loop's gone over all 10 items that we've had. Then we do our HTML templates like normal, write it out, and we're done. So if we were to refresh this page, we'll see the date times change, and it also did some CSS tweaks as well. But now we have our year, month, date, space, and then 6 p.m. And so there wasn't any major changes to the events HTML. The only thing that's changed was I just added in the Bootstrap's medium-sized breakpoint to change how it lays out. Instead of everything being one row, it'll just be a 2-column for desktop, 1 for mobile. It's the only change I've made on that. But we are still having our application serve up static files, which isn't exactly the most efficient way to go about things. If we go back in here, having your application do that's not necessarily the best way to do it. You can have App Engine do it. Just give me a second. Okay. So that's the next big change. Now for that we are changing our YAML file, and so we're adding in a matching here. So anything that matches /static/img we want to handle out of this directory, which is static/image. Now because we're doing static routes now, I had to reorder everything to be proper order because it wasn't matching the admin or the statics sense. I don't know why the App Engine works that way, but it just does. And so now that we've put that route in our app.yaml, we can actually take it out of our page, our site. And I also added in comments. But I removed the line that handled that static/image. And if we were to come in here, our image still works. And if we were to go to that route, it won't let you access it, but you can get the files within it. So it also adds in a little bit of security because people can't see within your static assets directories. And to prove that that's just not a cached copy, I'll blow in my cache reload, still there. And that is pretty much it as far as making a simple web app in Go.
That's pretty cool.
Any place we can see all this stuff?
Yeah, I will put it up on GitHub. I'll create a organization for the group,
Okay.
and I'll upload it there. And it is also already up on App Engine because I pushed it up just before starting this. So you can hit it by going to gdg/gigcity.appspot.com, and you can play with it there.
All right.
How do you deploy?
So it's a matter of creating a project within the developer's console.
What was that again? Gigcity or
Yeah.
appspot.com. Okay.
So you just create a project within here. So you hit that. It's a you give it a name and a project ID, or you can use whatever they generate. That project ID, you need to replace in the YAML file the application. So let me check this out. So my project ID for this actually ended up being GDG-Gigcity. And so I had to replace the first line in the YAML with what was in here. And then once you have that set up, you just come into here and do Go App Deploy.
So you don't have to set up any of the like the data store part or anything.
That's all there. And actually, I want to tell it to use OAuth. Yep, wrong place. Because I have my account under two-factor authentication, the normal authentication method for this doesn't work, because when you do Go App Deploy, it'll ask you for your email address and your password. The password I have, I can't use for anything but logging in via google.com. So I have to have special passwords for anything else. So if I'm using like Thunderbird to access my email, I have to have a special password for that. My phone has a special password. My tablet has a special password. That doesn't quite work for this. So instead they have OAuth. So you just run it. It will open up a browser, say what account, or log in with your accounts, and then it stores a token, and then it'll push any changes and then deploy it. And it's up. And then this will actually reload. But yeah, this is the developer console, so the more advanced version of this page. So within here, you can see how much you're going to get billed in the month if you have it enabled. You can do permissions. So like I'm the administrator or the owner, so I have full access, but I can add people in and say they have the ability to edit, or they can just view it. And I believe, yeah, so you can only set them to be one. It used to be like administrator, developer, and things like that, but they've changed that.
So you're using like another Google API there?
Yeah, I have an API set up because my personal website, I use OAuth through Google to actually do the authentication to hit the back end to it, and so that's what that key was.
It's not related at all to.
No, not really. Wow, it's taking a little bit. But you can set APIs and things for your apps. It has monitoring. So they announced even better monitoring in App Engine, but it's still not, or I/O this year, but it's still not released. So with this one, you can set up alerts. So if you're if something's happening, certain people can get alerted, so then they can know. So if you start getting a bunch of like 404 errors or 500 errors, things like that, it can start sending off alerts to certain people, so then they can start investigating it. And then it can hook into your source code. So since I'm gonna be pushing this up to GitHub, I can hook this into GitHub, and then this can access the files there. You can edit within here. You can do all kinds of crazy things. You can tag releases. And there's a debugger coming at some point. I don't know if it's going to support Go or PHP, but it does do Python, and it does do Java, and I think it will do Python, but they will be adding more as it goes on. And then you can hook it into the compute engine. You can manage your databases. So it hasn't created anything or entity yet, since we haven't actually ran and put anything up on the server. But you'll see the data there. You can run queries against it. You can see any indexes. And then the cloud storage is the data store. So if there were files uploaded, you would be able to see and manage them from that screen. Wow, these are kind of slow. All right. Well, that's pretty much all I had. Any questions? Anything go over? Clarify?
You said something about when you asked about logging in with the shell. You said you could use a VM or something.
So the way you can do it is App Engine works multiple ways. So there's the standard instances, which they run basically like a little container, a miniature operating system, just enough to run your application. And then those can be sharded across multiple instances to handle load. Or you can go the traditional managed VM route, where you have a Linux box that you can actually get access to. Downside to that is it doesn't scale like the instances route does, and you have to do that yourself, I believe.
And that VM, is that what they call Google?
The managed VM, the compute engines didn't. Compute engine's different.
Oh, okay.
That works similar to App Engine, except it has more CPU power than the App Engine instances do, because they're designed to crunch big numbers.
What engine?
Compute engine.
Compute engine.
And that thing's not free either, is it?
I believe there's a free tier, and then they do the same the paid quota thing.
I'm talking about the VM.
Oh, the VM?
I bet they've got a free tier on that.
They should have a free tier.
Yeah. Or else, not going to compete with
Because
AWS.
it's Google. They're going to have a free option.
Right.
And honestly, if they want to charge for the VMs, their free route's actually more flexible and scalable.
Was the underscore you had an underscore in front of your file name? Is that part of like Go, or is that?
That's just a personal convention.
Okay.
And that way, I can just look at the first letter and go, "Up, that's my base template."
Thought of it. Have you used any like frameworks?
There's some frameworks for Go out there, but the bigger majority is just use standard libraries and then pull in third-party packages as need be. So the more popular route is just like use the standard HTTP stuff, use the standard template, but if you need like special paths, like if you need to do variables within the path, things like that, then use a third-party routing engine instead of the one built in to Go. So like one of the more popular ones is the Pat by B. Mizrahi, and he based that off of Sinatra's router. So like, here, let me open up my Go source file here. So where I have all those HTTP handle funcs, you would use you'd call pat.new, and then you would say your whatever your variable is .get or .post. So this allows you to break out per methods. So you can say, even though the route's the same, look at the method and then call this different function based off that. Or you can do the query strings. So let's find a good example. Yeah. Also, good thing about Go, it's self-documenting. So this just pulled in all the pat packages and generated this. So we'll come into here. Yeah, so you can say hello and then some variable thing that's going to be there. So like hello, Mr. Mizrahi. Well, it'll pull in the last bit, and then that's what that is. Yeah. So hello / name will match any of those. The standard router built in, or the router built into the standard packages, doesn't support this. So it's just commonplace. Just replace that bit and then continue building.
And you had in your YAML file, like, did you have any other third-party packages how do you get them on the server?
It's a bit interesting. So say we wanted to use that. Within the root directory here, we create the import path. The way Go does import paths, it's wherever you got it. So github.com or code.google.com or launchpad.net, I believe is their domain, and then / whatever. So in this case, we're pulling it from GitHub. And then we want the user, so in this case, we're basically reconstructing this path right here. So B. Mizrahi. And then we can go into there. And then you just do a clone. Yeah, I'll make use of my GitHub client. Typically, you would have to grab this here to do your git clone, but the program I have, I can just grab the user and the program and say now we have that. And so next time you do a deploy, that will get pushed up along with everything, and then you just use that in your imports line like anything else. So we would GDG Go. Pull it in, and then we'll just replace the init with the Pat's way of doing it. But I don't really need to, because for what this site's doing, the standard router is more than enough. So I can actually blow that away.
Is there docs on the mustache templating?
Yeah, so it's since it's a Go standard package, it's all online. So we can go to golang.org. If you go to packages, you'll find all the documentation for all the standard libraries. So we were using the HTML templates. And so there's the documentation for it. Now the interesting thing about this, let's find a function. Like, let's use that must function. Say you wanted to see exactly what that did. Since the way this is generated is there's a program that goes through and reads the Go source code and then pulls out everything there to generate the documentation, you can click that line up there where it says the function and the name. It'll actually take you to the point in the source code file where that's defined. So you can see the functional comments, you can see the source, what that function's doing exactly. And this, for third-party packages, the godoc.org does the same thing, except it can pull from GitHub or Google Code or wherever and display that there in the same way. So let's pick one at random. Bigo. Bigo is one of the web frameworks that exists for Go. And this is all the documentation for it. So it read in all the source code files, pulled out the functions. So we have the function lists. And wow, this is a huge... And so yeah, and this will do the same. So if we were to click on this, like this assets.js, that will take you to where that function's defined, even though it's on GitHub. Because one thing that Go is strict on is your code must be self-documenting. So they should be able to run the go doc command on your code and get the information they need to be able to use your package or your program or whatever.
That's like, I don't know Go that well. Like when you reference GitHub in the import, that's not part of the namespace or anything. How does that work? Like when you're importing your Go file, you say GitHub.
That's how it namespaces.
It is, okay. So it is right.
Yeah, so the way it stores it is when you set up Go, you have to set up a path or environmental variable called GoPath that points to a I should have echoed it. That points to a directory on your system where it can pull things. So here it's my user / Go code, and under there it will create a bin directory, which is where it stores binaries it compiles, a PKG directory which stores binary compiled packages, and a source where it stores all the source code for things you've downloaded. So if we were to go into the source, so there's bitbucket.org, code.google.org, github.com, and then it also supports custom ones. So the honetf.co, that's a custom one, that's something I grabbed depended on. But from the source directory on is your namespace.
So the App Engine SDK is overriding that.
So it has its own environmental variables. So it has its own Go route, it has its own Go path and things.
I got it.
What has its own go path? What?
The App Engine SDK.
It's got its own go path.
So yeah, so when you run the Go app serve, it's running its own environment.
It's like a virtual environment.
Yeah.
Almost, yeah. So your prompt is cool. What's the hex number?
That is actually the commit number.
I figured it out.
So
Does that have Go bundled inside it, or what? The whole thing, or
what?
I mean, the SDK.
The SDK actually will have it has a version of Go in it. It has all the same packages that's available on Golang.org, plus all of the App Engine stuff.
Okay, so that means if you've already got say Go like on your system, but then you do the SDK,
Then you pull down
they're
the
separate.
you'll have two versions of Go just sitting
Two
there.
versions of Go. Okay.
One that's only used if you're doing App Engine stuff, and then the one used for everything else.
Okay.
How does it deal with the versions, like of the different libraries and stuff? If it's all globally in your path, is that anything to be worried about?
Well, not really, because the only way those can get updated is by manually. So we're getting out of App Engine context, and so let's see here. Go code. Let's see. Go. Let's see here. Let me pick one. Just to pick on one. Here. So the way you install packages is with the go get command, and if you want to update one, you pass the -u argument. So we'll tell it to update from GitHub NSF go code. And then so what it's doing is it's actually connecting, pulling down all the chain sets from Git since my last, and then it built it. So once you install something, be it go Git, it's just there, and the versions won't change unless you manually change it.
You don't have any problems with different versions and the way they work together or anything?
Because you only really ever have one version installed at a time.
Yeah.
Now, there are people who do these weird multi-paths and vendoring things, but even the developers of Go are like, well, you're just causing yourself more problems by doing that, because now you do have multiple versions of that library sitting around.
If you get some things that work with one and not the other, and I guess that's
Then it's just a badly built package.
Yeah, I mean, you can manage your own code now. You can build out a virtual environment and stuff like that. Somebody's probably done that.
There is, I don't know if it's still in development. There was someone who did a Go env. So it's just like the Python virtual thing, but
I'd rather not have to deal with it, but if it's possible that it does become an issue, then you don't want to start not doing it.
I've been using Go since it was first announced, and I haven't run into an issue. But yeah, this allows you to switch between multiple versions of Go and things, and you can have, and then there's things that do multiple or vendoring, so you can say for this project it'll use these packages that are this specific version, whereas this project uses those packages that are a different one. Yeah. But that's the issue, is now you have multiple ones laying around that are different, maybe different versions even. Whereas you should just write your packages to where they're stable and would work for anything. If it will break, then you make a note of it, and technically there's supposed to be a way, the go get command is smart enough so where I believe it's either the branches or the tags. So you can say that at this point it only works with a certain version of Go. So like if it only worked with Go 1.0, you would name your branch or your tag .1.0, and when you go get it, it'll go, that's one made just for my version of Go. I'll grab that one and ignore what's in master. So if you're going to break backwards compatibility, Go get knows how to handle it, but people have yet to do that because they have yet to hit that point.
Makes sense.
I think I may have actually seen at least one project that did that. Oh yeah, this was impressive too, since we're off on the off topics now. So someone wrote a URL shortener in Go. It is 81 lines long, including white space and everything. And they've only had to use one third-party package. And technically, they didn't even need to use that one, because the OS package has the ability to look up home directory. So they had a worthless dependency. Let's see if I can find it. I don't think it was this one. No, it wasn't this one. But yeah, here you go. So that Go-V5596, that was a pre-1 release of Go. So that's early stage Go, so it wouldn't go past that point if it wasn't newer than that version. And that was a development. I think he may have had another one that did the same. No, not that one.
Where's that SQLite 3 thing? Can I see that?
Yeah, there.
Where's that? It's in GitHub. Okay.
Yeah. So if you github.com/Matin.
Matin. Okay. /go SQLite Okay.
Yep. And the way you work with databases is very familiar if you worked with PHP's PDO or Perl's DBI.
Yeah.
So there's a wrapper that you call, in this case, is database/SQL. And so you would say SQL.open, give it the driver, and then the connection information to the actual database itself.
Okay. So before you replace your engine, you just use a similar line, and whatever's compatible will still work.
Yeah. And the thing about this, though, the naming of that function is a bit tricky. Even though it says open, it doesn't actually open a connection to the database yet. It creates a connection pool,
Yeah.
and then it opens and closes connections as need be from that pool. And so then what defer does is says don't run this until this function either returns or exits. So you're telling it to just wait and close. That way you know that way you've already handled closing out your database connections and everything. And so then he creates a SQL, and then you do like db exec and give it the SQL. At that point, it looks at that connection pool, sees if there's a available connection that's there
Yeah.
and that it can use. And if there is, it'll use that. Otherwise, it'll go up, create a new connection to the database, and run the query, get the data set back. And then once it's done, it marks that connection as being free, and it'll stay open for like 15 minutes or something like that before it closes. That way something else can reuse that connection. And then the SQL package supports transactions, so you can do transactions within it just by saying as long as the database supports it, that is.
Now,
So then you
where it's got the SQL package up at the top where you have that the database SQL, okay.
yeah. The database SQL is just like the PDI or DBO.
Like looks like DBI.
Yeah. And then since Go is UTF-8, you can put in kanji there and it'll still read it and work with it. And then it has 2 query functions. So let's pull up the documentation for this. There's one that pulls back a single row, and then there's one that pulls back all rows. Okay. So the if you call query row, it's only ever going to expect a single row to return from your query, whereas just the general query is designed to do multiple. And so you want to loop over that result set to make sure you get everything, which he does here. So he runs his query, and then you do a for to loop over it, and you say rows.next,
Yeah.
and then you pull out the data with the scan. You give it the values that you want it to write into via references, and then you just close out the row that tells you're done, so then it can go in and mark that connection as free.
So it returns height based on what's in the database, like ID and name.
So no, that's just the fields. So he's selecting 2 columns from that table, so it just does it in order. More advanced ones like the MySQL and Postgres, things like that, they support more advanced placeholders. So I know for Postgres it uses $ and a number, so then you can say like $5, $1, $2, and then it'll match them up. So like, yeah. Let me pull this into a someplace where I can edit it. This will never run, but that's fine. And we'll throw in address just for fun of it. And so, actually no, for that one it'd be the same, but if you did a write, so the write would do placeholders, so you can say 3, 1, 2, and so it was, now I'm gonna have to get my orders right. So it was name, address, ID. So for a write, it'll go, okay, a pull from the third value there, pull from the first value there, and pull from the second value there, whereas reading is all sequential. And see, here he's doing one using a placeholder. The SQLite, it's just a question mark, so that's still sequential. You can't mix them like you can with Postgres. Any others?
No, very cool.
All right. Well, thanks for coming out.
Thank you.